Hi, this video is about measuring VHP or vapor hydrogen peroxide. So I'm going to essentially jump straight into it. And I'm going to start off by talking about the technology that I have in front of me. So I have a Sensei or potentiostat slash meter in front of me. So I will actually be doing a demonstration with hydrogen peroxide very shortly. I've also got some sensors in front of me. In fact, I'll grab a sensor now-ish. And I'll just put that into the meter, essentially in preparedness. So let me just take a sensor, click this down, put another sensor in. That's done, and I'll just put these into the bin, which is done. Now it's probably worth saying that at ZP we actually this is a very old customer prototype, but this actually became CE marked and became a lot more refined. But this was actually a device that we did get onto the market using electrochemistry, and was actually collecting exhaled breath, and there we were measuring the hydrogen peroxide on the breath. But this is a very sort of specific application where we would breathe, we would condense the breath, then we would make an electrochemical measurement on it. That's not something that we have readily available through our web store. To really access that kind of technology, unfortunately these days now is much more of a big program. But what I will talk about is what we do have available, let's say more readily, which will be the hydrogen peroxide sensors. Now the inquiry itself, if I just kind of read it, they want to detect hydrogen peroxide in the atmosphere. So this is sort of VHP at 10 to 100 parts per billion. And I've just been doing some calculations upon it. Now the reason I kind of have this in front of me is because this meter will actually do, it'll cool the breath, it will condense the breath vapor, and then it will measure the hydrogen peroxide in the liquid phase. A lot of what we do at ZP is in the liquid phase. So what I'm saying is that we don't readily have, for doing scientific studies, a VHP, a vapor hydrogen peroxide system. We do have this guy, but this is something that we would have to reposition from the medical world. But what I do have is the Sensei Ore, which I will talk about and do a quick demonstration of in a minute. But I just want to do a quick sort of back of the envelope calculation here and just kind of say, okay, so I just looked this up online, and I think that under normal or standard temperature and pressure, the density or the density of vapor in the atmosphere is about 0.0048 grams per liter. These are back of the envelope calculations. I kind of know that if we can condense vapor out of the atmosphere and into a condensed phase, a liquid phase, then that will obviously go to 1,000 grams per liter. Now that's really a sort of an enrichment of about 200,000 times, close to 210,000 times. The reason I bring that up is because though we do have vapor hydrogen peroxide systems specifically for condensing the breath, we don't readily have something for the scientific kind of study. But if people do have a way of condensing VHP, in condensing it, it will take something like, first of all, let me just do my back of the envelope calculations, which I will do here. So 0.048 grams per liter, which is approximately, I think about, was really quite low. If we condense it, it'll go to about 1,000 grams per liter, which is about a 200,000 or 210,000 almost enrichment or condensing of the sample. That means if we have something that's 10 ppb, 10 parts per billion, or something that's 100 parts per billion, which is the kind of range that the inquirer is interested in, then by condensing it, we'll bring that up to about 2,000 parts per million, or even at the higher range at 20,000 parts per million. These are really high concentrations, by the way. So what I'm saying here then is, if the inquirer has the ability to actually condense the sample, then it will naturally enrich the sample. and I mean that kind of enrichment, those kind of levels are really straightforward to actually detect. And in fact, I'll do a demo like that now. So I've got the word demo here. I'll just go to an external screen. I'll just go done here. So what I have in front of me here is the Sensi All instrument / potentiostat. I'm just going to label up my data so I can find it in a bit, which I am now doing. What I'll do is I'm just going to put a solution on there that doesn't contain hydrogen peroxide. So I've got a clean pipette in front of me. I will put a sample onto this. The nice thing about this system is you don't need to condense a lot of material. This is only 50 microliters that I'm actually putting onto here. I will just do a quick continue, start. So I'm now gathering essentially data, but there's really no hydrogen peroxide in this. But in a minute, I've got I'll put a clean pipette tip on here. I'm just going to drop in a little bit of hydrogen peroxide. Now I'm actually dropping in quite concentrated hydrogen peroxide, but I'm only going to put a little dab in here, which I would put in there like that. You see that little jump up there, and that's the kind of hydrogen peroxide. I'll put a bit more of a drop in there, and then the hydrogen peroxide goes up a little bit more, and I'll put a little bit more of a drop in there, and the signal will go up a bit more. So what I'm doing there is basically sort of essentially titrating in hydrogen peroxide. You can sort of see the signal go up accordingly. So we do have a system for measuring hydrogen peroxide. Doing it in the vapor phase is hard for us outside of the medical industry, even though we do have quite sophisticated cartridges for it. If you can condense the vapor phase to a liquid phase, it does a couple of things. It enriches the sample, which makes life so much easier, and then it actually means we can use it on this quite simple instrument here. And the nice thing about this instrument is, and the nice thing about a lot of electrochemical instruments is, you don't need a lot of sample in order to actually in order to do an electrochemical test on it. What I might do now is I'm just going to go to an online system that we have called Julie, and so any data that we gather will automatically be put up into the cloud. So the app will talk to the database, and then all data is measured, and it will actually come up here, and then we can actually see. Let me just go here. Just do a quick refresh, and then I can see my hydrogen peroxide 2 data, which is the one I just measured. And then I can see where we had no hydrogen peroxide, and then I was adding in more amounts of hydrogen peroxide. You can see the final one here is, there was an addition here, there was a little addition here, and I did an addition here as well. And you can see the hydrogen peroxide. I say you can see it, and I realize I'm not actually sharing my screen with you. So let me just share that screen with you here. So we have a system called Julie. All data that's gathered goes up to the cloud, and then I can see the signal here, see the signal here, see the signal here. So you're never asking the question, where is my data? Because you always know where your data is, because actually it goes straight to the cloud. So if you have any questions, I just want to kind of finish with a final comment, which is, if you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.